Hi, everyone. Thank you for coming to my talk on how to build next-generation data pipelines with containers. My name is Karolína Netolická, and I'm a product manager at Google Cloud. I work on Cloud Run. So we've all heard that data is at the heart of modern applications. It's used to make business decisions, improve products and services, and create new opportunities. And this is becoming even more true with the rise of AI-driven applications, because your AI-powered application's only ever going to be as good as your data. So today we're going to talk about 3 types of data processing. On-demand data processing. Oh, well, look at that. Slides, that's not my slides. But those are my slides. Thank you. Ah, there we go. Let's go a little bit backwards. So we're going to talk about 3 types of data processing: on-demand data processing, batch data processing, and streaming data processing. And I'll show you how to build these pipelines using containers as our basic building block. Containers, of course, are the standardized, immutable, basic building block of modern cloud-native applications. And they're the next evolution step in the move from on-prem hardware to virtual machines to now containerized applications, each step progressively abstracting away more and more infrastructure. And containers give you 2 really important things. The first is flexibility. Flexibility allows you to use any framework and any language so that you're not limited to what a particular data processing platform offers, but can choose what's right for your application and your organization. And portability lets you move your container to the best compute platform for your use case. And what I mean by that, this slide shows different ways that you can run a container in Google Cloud. Say you start with Cloud Run, but then you find that you actually need access to local disk. No problem, you can take that same container without rebuilding it and move it to GKE Autopilot. Now you can access local disk, and you still have a pretty fully managed data platform, container platform. Or perhaps you decide that you need to use a processing algorithm that requires fast inter-node communication. For that, Google Batch is a great choice. So you take your container and you move it to Google Batch, which is our product that supports high-performance compute use cases. And you can keep moving to the right, accessing more and more layers of infrastructure, but of course, at the cost of having to do more and more operational work. So I'm going to state a principle. I think you should always start with the product at the highest level of abstraction that works for you, and only move towards less managed products as needed. So for container platforms, that highest level of abstraction product is Cloud Run. And I'm going to talk about Cloud Run quite a bit in this talk, so I'm going to give a really brief overview. Cloud Run is our fully managed container platform. It's a great fit for a variety of serving and data processing workloads. And we designed Cloud Run with simplicity and automation in mind to get you as fast as possible from prototype to production application. And because Cloud Run runs containers, you get that flexibility and portability that we talked about. So without further ado, let's talk about on-demand data processing. So on-demand data processing is when you have some data and you need to process it on an ad hoc basis. Perhaps you need to generate a business report, or perhaps you need to migrate your database to a new schema. And you probably don't want to run this on your laptop. In fact, hopefully you don't actually have production access from your laptop. So you also don't really want to have to create a VM and install software and all of that. You want an easy way to run your script in the cloud. And so Cloud Run jobs are a really good fit for this. This is how you run a batch script in Cloud Run, bash script in Cloud Run, assuming you've already built your container using either Docker build or Cloud build. You run gcloud run jobs, deploy, you give it a name, and you tell it where your image is. This is going to create a Cloud Run job, which is essentially an object that encapsulates your container, your code, as well as all the configuration around it. And then you run that job with a really simple command. Cloud Run jobs, just like Cloud Run, are fully managed. You deploy your container, and Cloud Run takes care of scheduling your instances and stopping all instances when they're done so that you only pay when the job is actually running. And Cloud Run jobs work with all common data storage solutions so that no matter where your data is, as long as it's stored either in a Google Cloud managed storage solution or is accessible from your VPC network, you'll be able to process it and access it using Cloud Run jobs. So eventually you might end up with jobs that are pretty large. You need to process a large amount of data. And sometimes you're in a situation where you want to get to results fast, perhaps because that business report is due, in an hour. One way you can make your jobs run faster is by parallelizing them. What this means is you break up your job into multiple tasks, where each task is a running copy of your container. And each task is aware of its task index, as well as the total number of tasks. And you can use that information to structure your code in a way that each task does a simple computation to figure out, is this input for me or is this for one of the other tasks? So each task processes only a subset of the input. And so I'm going to show you what this looks like in Cloud Run jobs. So I'm going to create a job. My job's being created. I pick a container, and I tell it how many tasks. So we're going to run this with 100 tasks. So nothing's running yet. And now I click Execute. And let's take a look at it. So what Cloud Run's doing right now is it's scheduling 100 instances of this container and starting them. And this is a real-time video, so we're all going to sit here for a little bit and watch this spin, because I wanted to show you how fast this is. And just like that, we have started and finished running 100 containers. So of course, this sample container doesn't do a whole lot, but still, running this many containers this quickly is, I think, pretty unique. Now you might say, Karolína, that's all nice, but I don't really want to change my code to tell each task which input to process and deal with parallelizing my jobs. I just want to take my existing long-running job and run it in Cloud Run without having to do anything extra. And if that's the case, I have good news for you, because Cloud Run jobs now support up to 24-hour timeouts. So that means that each task of your job can run for up to 24 hours. So as long as your job takes less than 24 hours, you can just deploy it to Cloud Run, and it will run to completion. So that was on-demand data processing. Let's talk about batch data processing now, which is much the same. You have a bunch of data, and you want to process it all at once. But the big difference tends to be that you want to orchestrate it in some way rather than click, execute. Here are some common times when you need to do batch data processing. For example, if you are maintaining even a very simple web app, you'll find that you need to have various pipelines that handle deletions so that if one of your users deleted their data, you want to make sure you've actually deleted from everywhere in your system. You want to probably periodically audit your access control list so that the right people have the access to the right information. You might have some database management scripts going on, as well as business analytics scripts, because you want to make sure that your logs and user data is exported to a format where you can actually use it to make business decisions. And so one thing we did in Cloud Run jobs to facilitate batch pipelines is that we clearly separated management of jobs from running of jobs. So you saw earlier that you create a job and then you run a job. This lets you manage your jobs with an infrastructure as code approach, for example, using Terraform or config connector. That's how you would manage, updating the container, for example. And then you can manage the actual running. You can treat the running of jobs as a data plane operation. And so you can easily run your jobs programmatically using either an API call or a client library, or orchestration products like Google's Cloud Scheduler or workflows. So let's take a look at that. So I want to show you how you would set up a scheduled job in Cloud Run Jobs. So we go to the Cloud Run Jobs page and click Triggers, Add Scheduler Trigger, and I'm going to tell it when it should run the job. This is cron notation, so I'm going to ask it to run it at 2 a.m. every morning. Click Create, and just like that, my job's now going to run at 2 a.m. every morning. So it's really easy to go from I have a Cloud Run job to let's schedule it to run regularly. As your jobs get more complex, you'll probably get to a point where you might have multi-part jobs that you want to chain, where each successive job uses the output of the previous one, perhaps with some conditional logic in between. Cloud workflows are a really good fit for this. They're also great for error handling, because a cloud workflow will, with the jobs workflows connector, will run your job, wait for it to finish, see if it succeeded or failed, and then you can do further handling based on whether it succeeded or failed. So this is great for error handling, kind of outside the Cloud Run Jobs retries. And you can even set up this workflow to run on a schedule. So if you want to run your cloud workflows, I don't know, every morning at 2 a.m., you can set that up using Cloud Scheduler as well. Cloud Run Jobs can also be really useful for background processing, where a user action results in some larger set of operations that you want to do later. For example, that deletion pipeline I talked about, imagine a user deletes their data. You don't want to kind of block that operation. You want to return success to the user, and then in the background, later, you go through your systems and you do all your deletion. So Cloud Run Jobs are a great place to offload such processes, to get them out of the critical user interaction path. And here, Cloud Workflows can help again. So you wrap your job with a workflow, and then you set up event triggering for your workflow. Now you might think, how do I get the event payload into the Cloud Run job? And so I'm excited to announce that we have added execution overrides to Cloud Run jobs. And so thanks to this feature, you can parse out the event payload from the event, and then have your workflow pass that event payload to your job, either as an environment variable or as arguments. So execution overrides let you pass in some information every time you actually execute the job. So they override existing settings in the job without changing the underlying configuration. You can override environment variables and arguments. And this is useful to tell the job, for example, this is where the input is located this time. Or perhaps, to pass along that event payload. You can also override the number of tasks. And this is useful if your job is written in a way that each task processes exactly one piece of input. So you tell your job, this time, please run 12 instances because I have 12 pieces of input. And lastly, you can override the task timeout. This is useful when, so Cloud Run jobs only charge you when the job is actually running. But as we all know, sometimes we make mistakes and get infinite loops. So it can be useful to have a task timeout set kind of close to how long you think the job ought to run if there's no issue. And here's how you actually use Cloud Run jobs with execution overrides. So we've got an execute button up there, but instead of clicking that, we'll click the little arrow, execute with overrides, and now here I tell it what new values I want to set. So I filled in here a new value for the bucket environment variable. And so when I click execute, this job would run. So to sum this all up, you want to use Cloud Scheduler with Cloud Run for scheduled jobs, Cloud Workflows with Cloud Run jobs for complex workflow orchestration, and Event Arc with Cloud Workflows and Cloud Run jobs for either event-driven jobs or entire event-driven data pipelines. So finally, let's talk about streaming data processing. Yes. Streaming data processing is great because it's conceptually simple. An event happens, and you process it. In general, there are two major paradigms when doing streaming data processing. We've got push-based and pull-based. Push-based is when your queue is pushing events to your compute endpoint. And pull-based is when your compute is actually workers that are running all the time and pulling work from your queue. So traditionally, for serverless pipelines, people have used a push-based model. So what this looks like is you tend to have an input source, for example, cloud storage or cloud logging. Then you have a queue system. That could be Cloud PubSub, Event Arc, maybe Kafka. And then you have some sort of endpoint, serverless endpoint, automatically scaled, like Cloud Functions or Cloud Run. That does the actual data processing. And then finally, you write out the output to some place like, for example, BigQuery or a database. And this works really well. There are a lot of customers using Cloud Run and Cloud Functions for this type of use case. It's easy to set up. Cloud Functions, for example, even has built-in Event Arc integration. And it automatically scales with traffic, and you don't pay anything when you don't have any events. So you might ask, should I use Cloud Functions or Cloud Run? And the answer, in my opinion, is, again, use the simplest thing that works. So if your processing code is really a function, use Cloud Functions. It's the easiest to get started with. You don't have to write a Docker file, so you don't have to master build systems. And it's got built-in support for events. You might want to use Cloud Run, on the other hand, if Cloud Functions doesn't support the language that you want to use, or if you want that container-level portability, or if you want control over the build system, for example, for compliance reasons. So now let's talk about pull-based data processing. You want to use pull-based processing if you have a really high throughput, if you have a really high volume of messages and need to achieve high throughput, or if you need to achieve low latency. And the advantages of this kind of paradigm is that twofold. One is that when you're doing push-based processing, you have really an HTTP request for every piece of input data, right? So that's overall less efficient. And so it's hard to get the same amount of performance. And push-based processing also gives you better control over smoothing out traffic spikes. Because in your streaming processing pipeline, if you're using a push-based model, if you have a huge amount of events show up at a time, your compute's going to scale way up, hopefully fast enough. And then if you're using a database, for example, as your backing resource, you might end up in a situation where you have too many workers trying to write to your database. With pull-based processing, you can control this by controlling the number of instances a little more yourself. So let's bring this back to how would you use this with Cloud Run. Again, you have an input source, you have a queue, but this time you have a pull subscription to PubSub. And you set up your Cloud Run service. This time you want to use Cloud Run, not Cloud Functions. You set up your Cloud Run service with CPU always on. What this means, by default, your Cloud Run services only get CPU allocated when they're actually processing requests. because this lets Cloud Run give you that great billing model where we only charge you when your service is actually processing a request. But when you're doing streaming data processing, when you have pull-based workers, you don't have any requests coming in, so you want CPU all the time. So you set CPU to always allocated, and then you set your min and max instances. Now, until recently, I would have told you you want to set min and max instances to the same number, because Cloud Run scaling was built around request-driven workloads, and we cannot scale this. However, I'm happy to announce that in the coming weeks, we'll be rolling out a new feature where we'll scale based on CPU utilization, even when your service isn't processing requests. So you'll be able to set min instances and max instances to different values, and as long as your workload is CPU bound, we'll be able to scale up your service up and down based on the volume of incoming messages. So that was a lot of content about serverless products, but I wanted to make sure you got to see an end-to-end example of how an actual customer uses this for their system in production to generate business insights. And so I spoke to Antoine Castex from LOreal. Unfortunately, Antoine couldn't be here today, but he sent me this great architecture diagram. So the team at LOreal loves BigQuery. So one of the design goals over here was to get their data into BigQuery as quickly as possible, as efficiently as possible, and then use SQL and BigQuery's advanced features to generate insights and process it from there. So starting on the left, we see all the data sources. There's a lot of different kinds of data here. Sales data, product data, external data sources, logs, and so forth. And they're processing 150 petabytes per month these days. So the moment data arrives, it triggers either Apigee or gets written to cloud storage. And that generates a trigger that triggers a Cloud Run service. And that Cloud Run service does two things. First, it writes the data to BigQuery. That's the whole we want to get it into BigQuery as quickly as possible step. And then it generates an event that triggers a cloud workflow. And that cloud workflow takes the data through a series of transformations, with various Cloud Run services actually doing the compute work of transforming the data and writing the results into that shared BigQuery data set on the right. And then to actually use this data, they've defined a few separate BigQuery views so that different internal stakeholders can view the right amount of data based on what permissions they ought to have. And then finally, they've built several different ways to actually consume that data for end users being business stakeholders inside the company. So they have a web front end, built-in app engine. They also use Looker as well as third-party dashboards. So using all serverless components, LOreal was able to build an end-to-end data warehouse pipeline that's increased their efficiency and lowered their maintenance costs. So putting it all together, in this talk we showed you how to build serverless pipelines for data processing. You want to use Cloud Run jobs for on-demand and batch processing, Cloud Run services for streaming data processing, both push and pull-based, and Cloud Functions for event-driven data processing. And this is all powered by our constellation of orchestration products and our great suite of serverless data storage products. So I hope you give this a try on your next project.